Several students have raised some concerns about the midterm and its operations. So the midterm is basically a exercise in digitizing as well as utilizing the skills that you learned in one of the labs in remote sensing that's contours to DEM. So the first thing we're going to do is download the data. I've already done that, but you'll find the data for it in the learning modules. And the midterm is in assessments. So in assessments, you'll find Geography 4960 midterm 2019. You want to left click on that and then download that, unzip it, and put it in a folder that is named your surname midterm Geography 4960 or something like that. The second thing you want to do if you want to look at what is in there, we'll left click. I've already got it downloaded and I've got it unzipped anyways and not in a folder because I'm not going to go through the midterm with you. There are two things in there. The midterm instructions, and the midterm instructions involve two essays and the lab exercise. So you respond to both essays and then do the lab exercise and turn it in like you would a normal lab exercise that you would have done for the introductory course. The other bit of information or data that is in that particular zipped file is a Kilmartin 1924 GeoTIFF of the site core at Chichen Itza. So we'll take a look at that. This is a GeoTIFF, by the way, so you know what to do with that. It's already geo-referenced and it'll pop into place. If we zoom in, you're supposed to digitize the contour lines, so all these lines. These lines have elevations assigned to them. They're in feet. The Carnegie Institution for Science worked in feet in Mesoamerica when they did surveys, so you'll digitize these contour lines. What you should do is if a contour line intersects something like a pyramid or a platform or something like that, continue it through if you can and find the other contour line it should meet. The convention for contour lines is that they must connect. So there's no dead ends, except like here at the neat line where this contour line, and that's 90 feet, starts here, ends here, and it probably continues out around that way. But that won't interfere with what you have to do. So that's the information you have from the midterm. So what we're going to do now is go through the basic operations. So you can all digitize that. Everybody knows how to digitize. And the attribute, the only attribute you want in that particular database or Microsoft Access database is a attribute for elevation, abbreviated all caps ELEV, and it's numerical. So in the learning modules, topic 3 is lab contours to DEM in GeoMedia Grid. You should have done this lab. I'm going to walk you through the operations for this lab. There are a couple hiccups because when this lab was created, it was on a different computer and in different files. So you're going to have to change some file paths when you get through this, but it's not a very difficult thing. So the first thing we're going to do, I downloaded that to a folder, and I believe the folder is named Weinmiller contours to DEM. In any event, we're going to launch GeoMedia, and it'll take just a second. And I'm kind of paging through this lab with you. There are a few things that the lab leaves out, so we're going to agree to that nag screen. Okay, here we're going to open an existing one, but we're going to left click on more files, click OK. I'm going to go to my computer, which is named Magellan, double left click on my C drive, go down to Weinmiller, contours to DEM, and there is already a geo workspace there, contour to DEM, so we're going to open that. And we're going to get a file path issue here. Right there it is. And what it's looking for is contours to DEM, which is a file folder that I don't have, and contours MDB, Microsoft Access Database. That's what it's really looking for. So all you do is hit left click to browse, get into your computer again, scroll down to the folder you opened, left click on contours MDB, open, and OK. So that should get you up and running. And there it is. We're going to left click to get a full map window. I'm going to fit all. I'm going to right click, and I'm going to position legend to the left. That attaches it in a way that you're familiar to look at. We're going to fit screen again. So here we have a bunch of contour lines, and if we left click on one of them, you'll notice that it has an elevation assigned, 1480 meters. These are in meters. Okay. And these are steep, so that's 1680. So this is a very steep slope. If you know anything about contour lines, and you should if you've had 3940, the closer the contour lines, because they are at intervals together, so the more dense contour lines, the steeper the slope you're dealing with. So what do? The first thing we're going to do is we're going to assign a study area. So we're assigning an area or defining it where we're going to perform a particular operation. So left click on the grid tab, and in the study area panel, we're going to define new. Left click. You're going to get a pointer. So I'm going to start like right up in here, pull it down all the way to here, and pull it over. Do not go outside the boundary of the existing data set. So I'm going to left click, and I think you're supposed to call this study area DEM 15 meters. We're going to set the cell resolution to 15. That's basically the size of the cell, and the units we're going to set to meters, and we're going to click OK. So now we have a study area, raster-based operation. So, and it's an add-on to GeoMedia. So you're going to have to rasterize whatever features you're working with. So what we're going to rasterize is center line. That's what we just clicked on. And we're going to go up in layer, and we're going to left click on rasterize legend entries. It automatically recognizes that. Defined, and that's where we'll be performing all the operations on these contours. Okay, on the grid panel in layer, We want to look for information, random sample, click OK. And here's the information from that particular previous operation. You can take a look. There are 523 rows, 740 columns, 81 zones, 387,020 cells. Maximum value is listed there. Standard deviation, so some statistics. Cell resolution 15 meters. We want to set this to meters. So set your data units to meters and click OK. Now we want to click Edit, Random Sample Result Layer, Edit, and let's take a look at that. Pull this out of the way again, maybe zoom in once. And now you'll see that we just have pixels instead of lines. And if we pull up our Query Raster Values tool and roll it around, you'll notice we have pixels with elevation assigned to them. Coolio, Joe. Close that. Don't have to save. Okay, once again, now what we're going to do is we're going to use the spline command to create a surface. So now we're going to make a surface out of this. So it's going to do the interpolation between all of those pixels, assign values to it, and create a surface. That is not a geotiff or a DEM yet. So on the grid tab, we want to do analysis, interpolation, spline, random sample result layer as the source layer. We want to set the precision units to meters again and accept all other results. Now you notice there's attribute here, but there's nothing in there. There's no mask layer. We don't want to place this in the map yet. So we want to accept all those default values except changing the units to meters. Click OK, and you'll notice your blue bar advancing. Okay, so that's done. So what we want to do now is we want to smooth out the surface. Why would we do that? Well, during interpolation process, you may get spikes or you may get pits in the surface. We want to get rid of all of those. So we're averaging the cells around a particular value and kind of smoothing everything out. So we're going to click grid analysis again, and we're going to do surface. And this time we're going to go down to smooth. I don't recommend this all the time, but sometimes we do. We want a round cell. We want window size of 11, so it's going to go out 11 cells around it. We want to leave it mean. It's going to call it a smooth result layer. Here we're going to go spline result layer. There's no attribute yet. Let me see if there's anything else in here that I would need to check. Nope, I don't think so. I think we're good to go. It's smooth result layer. We do not want to place this in the map window yet, so take a check out of that box. So you notice as we go through this, we're progressing down through the derivatives of the previous process and continuing to process the data. So click OK, blue dots go across again. Finished. Okay, now we're going to remove depressions. So we've had some spikes taken out of there, smoothed everything out. So we'll grid lab analysis. We're going to go to surface again, fill depressions. This time, smooth result layer. Left click, that's the last feature we did. And we're going to name the result layer DEM. So we're going to change this to DEM and click OK. Take this out, take the checkbox out. This takes a little bit longer, some more math. Okay, let's go ahead and click on the edit window. So edit, here's our DEM, left click that, left click edit. There's your DEM that you generated. You've seen these before. We're going to move this out of the way, scroll down. And we're going to left click on the uppermost value and we're going to scroll down all the way to the bottom, hit the shift key, left click. We're going to right click on that and we're going to left click on color sequence. There are different types of paths that we can play around with. We leave this as sequential. Let's left click on the lower value and I'm going to do dark green. Left click on the upper value and I'm going to do sort of a red and then play around with the sequences. So this one will go from green through blue to purple to red. That one will go green to dark red. This one will go greenish yellowish to red. I kind of like that. Click OK. And there is your colored DEM. We can scroll down on here and notice that higher values, so it shades from green to yellow to red. So what we're going to do here is we're going to save that and I believe we'll close that right now. Save button and close it. So that's saved. Now let's go ahead and do shaded relief. So in the grid tab, click analysis again. And this time we're going to do visualization. Shaded relief, left click that. And we're going to select our DEM in the left. And on the right, we're going to just kind of scroll this around. Let's try smoother. Click the show button and you can roll this azimuth around and it changes the look of it. I'm going to put it at northwest finally. And that does show not the entire portion of the surface. So let's place results in the map window. It's called shaded result layer. Click OK. And there's your shaded relief. Okay, here's what we're going to do with this. we're going to, number one, save this geo workspace. I'm going to show you one other operation that's not in here, and that is to export this as a geotiff, and we're going to that geotiff will have the elevations in it. So first thing I'm going to do, I think, is well, let's go ahead and save this. Go into my folder. And instead of contours to DEM, I'm just going to say Weinmiller. Save. I'm going to list the layers here so you can see all the layers we have. Okay, so this is saved right now. Let's left click on display and let's do DEM. Okay. There's your DEM. So that's on display. Now, what do we want to do? We want to go to layer. We want to go to export to file. We want to export our DEM. Click OK. And we don't want bitmap, we want TIFF. And we're going to put this in our folder. It's reversed. And I'm going to call it Weinmiller DEM. TIFF, save. Now, it's asking you for data 32-bit, RGB 24-bit. You have to put a check in the radio button for RGB 24-bit for it to be a geotiff. Click OK. We're going to go ahead and go to Home, Legend. Well, no. Let's go up to Raster, geo-referenced. We'll leave it automatic. We're going to select our folder. Weinmiller DEM, okay, and it's Weinmiller DEM TIFF. Pull it over there. You'll notice nothing went wrong. No coordinate system file needed. Add new, and we'll call this Weinmiller DEM geotiff. It applied it right there. I'm going to take the DEM out and take the shaded relief off. So if I turn this off, we're back to contours. Okay. So now we have a geotiff. So I'm going to save this one more time. That's basically the exercise plus. And the plus is to output a geotiff, because if you don't have the geotiff DEM, you have nothing to work with. We could put this in GeoMedia 3D, but I'm not going to do that right now. We're going to go ahead. I'm going to minimize. Well, I'm actually going to open up Envy 5.5. You have access to that. Takes a bit to do that. And we're going to look at this in 3D. This is not part of your midterm. This is just having fun. And I know you all are having fun. Okay, you'll notice I have a toolbox to the right on my Envy screen. There's no data in here to view. So I'm going to go to left click File, Open. I'm going to go to the C drive, go down to my folder, or up to my folder, whichever way this silly machine decides to do that. Weimiller DEM TIFF, open. And there it is. Okay. So if we went with a cursor locating tool, you can see the Latin lawn. As we click around, we'll close that. We're going to double left click on 3D surface view. It's Weimiller DEM. We're going to left click band 1 for red, band 2, and band 3 for blue. Click OK. Now all we have to do on this screen is click band 1. OK. Here we're going to let it go full. If you have a machine that doesn't have a lot of RAM and doesn't exactly have a fast processor or multiple processors inside, it's going to take a much longer time to do full. Sometimes the machine will crash. We're going to leave it at that. I'm going to change the vertical exaggeration to 2, and we'll play with that in just a minute. So vertical exaggeration, if you remember from cartography and from some lectures or PowerPoints, you're vertically exaggerating the vertical scale, not the horizontal scale. Image resolution full, we're going to do full scene, click OK. There it is. We're going to open up this box by getting in that corner and zoom in and out, and I can use my mouse keys. My left clicker will, now you notice we don't have a lot of relief on there, and we can increase that by looking at surface controls. Pull this a little bit out of the way here, and you'll notice on vertical exaggeration we're set at 2. So I'm going to pump it up a little bit. You notice it's changing. So if I go to 7, now we can see those contours. The problem with vertical exaggeration is that in the real world, you're distorting the relationship between horizontal space and vertical space. But in order to make a pretty 3D rendering that shows you variation in elevation, sometimes you have to exaggerate. You could go crazy with this and put it up to about 10. And then you can see the difference. Clearly, the variation between the horizontal and the vertical is in no way like that. So, if you have any questions, feel free to write me. Remember that the Contours to DEM lab, you have to familiarize yourself with that before you do the midterm, because what you're doing is you're basically taking a contour map that's geo-referenced already, you're popping it into GeoMedia, you're digitizing contour lines, putting elevations attributes on those contour lines, then pulling that map into GeoMedia and going through all the steps we just did in Contours to DEM. Then the last step, the final step, is you click Layer. You want to export it to a GeoTIFF. You select the 24-bit RGB because that's the only one that preserves the elevation and the color shade that you decided on. You export that, and then you can open up Envy and pull it into Envy. So with that in mind, I hope this video was helpful. If you have any questions, call me or write me, and we'll take care of those questions.